Hey everyone, welcome back to another video of mine. And if you guys haven't noticed from the previous video, I actually fixed my audio issue. So I decreased the background noise and made sure that you guys can actually understand what I'm saying. So without further ado, let's go ahead and get into today's video. So in today's video, we're going to be learning about the binary search algorithm. And as usual, I will be conducting this video in Python. Okay, so if you guys are wondering what code editor I am, of course I'm in the standard VS Code editor algorithm. Sorry, there should be an H there. Okay, so I'll give you guys a very basic real life example to kind of just represent how we actually implement the binary search algorithm in real life. Okay, so let's just assume my friend and I are playing a game where my friend has a list of numbers where all of those numbers on the list are actually within the range from 1 to 100. And the very key part here is that list has to be sorted. And you guys will see why in a bit. So in each round of that game, my friend is going to give me a certain specific target number. And I have to just tell him the indice that target is at within that list. Or basically the position of that target in that array nums. Okay? And the average person here would simply start from the 0th index here, the first value inside of the list, and keep checking every next value from there inside of the list until we actually get to that desired value as the list is actually previously sorted. However, as the input size grows, this should actually be very, very slow and time consuming, or O of n, big O of n if you guys are familiar with time complexity. Whereas binary search is actually big O of log n, where n is the size of the input, or in this case, the size or length of the array that we're actually scanning through. Okay, so with that out of the way, let me just tell you what the binary search algorithm actually does. The binary search algorithm actually uses a two-pointer technique to get the middle index or indice of the nums array. And it compares if that nums at that middle index is less than the target. And if it isn't, it starts changing the 2 pointers until it keeps cutting our it keeps cutting our list in half until we actually find our desired value. And we'll do this like so. We'll define a binary search function. We'll take in 2 arguments. One is the nums iterable, and the other is a target value, like I explained in the problem, in the real-life situation. And then I'll get our 2 pointers. I'll get our 2 pointers, and those are going to be left and right. Our left pointer is just simply going to be the 0th indice of the array, while our right pointer is the length of the nums minus 1. And the reason why we do minus 1 and not just length of the nums is because if we were to do length of the nums, that would be 1 greater than the last indice of the nums array, as the nums array in Python indices actually start at 0, not 1. Now, we actually have to use a while loop to check while our window left is actually less than the indice value right. In this case, it's a valid window. We can actually get our middle indice. So we'll set our mid equal to the sum of these 2 pointers, left plus right, not tight, sorry, it should be right, and we'll divide it by 2. Okay. And if you guys aren't familiar with these double slashes, this is basically just integer division in Python, which simply just rounds the quotient down into an integer, hence the name integer division. Quite simple. Okay. And now we actually have to use conditionals to check if we have found our target value based on that middle indice or not. So if that nums at that middle index, as defined up here, is actually equal to our desired target, then we've actually found the number that we were looking for, and we can simply return that indice. If we wanted to return the actual value, we'd simply return target or nums at mid. Either one works. Okay, but of course here we want to return the indice, like this. However, we have to use another elif statement for conditionals, and if the target is actually less than the nums at that middle indice, then we actually have to cut our input size in half. And we have to do this by setting our right equal to the middle indice minus 1. And sorry, there should be a colon here. My bad. There should be a colon here. Oh my. And we have to indent this, of course. Okay. And the reason why we set our right equal to the mid minus 1 is because we know that we have to remove the right half of the array due to the fact that it's sorted, and we know that our target is going to be in the left side of the array because it's less than the middle index. And that's the key why it's so important. And I'll give you guys a quick array just to show you guys how that works. So if I have these numbers, right here, of course, it is sorted. I could get the sorted version of it like this with Python, but it's not necessary as it's already sorted. Okay, so basically, or actually, I'll just finish the code up first. So I'll say else, and essentially what this else statement covers is if the nums at mid is not equal to the target or less than the target. So basically, nums at mid is actually greater than the target, then I actually have to set our left pointer equal to the middle indice minus 1, or sorry, plus 1. Okay? And that will essentially cover the right side of the array because I know that our desired target is contained within the right side of the array. It's one of the greater, integers within our array. And of course, if I don't actually find a valid indice, I can simply return -1. -1. And let's just go ahead and visualize this. So while our left is actually less than right, so while we actually have a valid, a valid array with a correct window, we'll set our middle indice equal to the sum of our 2 pointers and integer divided by 2 to get that middle index. If the nums at that middle index is actually equal to the target, then we have to return mid. So let's just say our target was 9 here. Okay? If nums at the middle index, let's just say here, is equal to 9, then we can simply return the middle index. In this case, the target is if the target is less than nums at mid, we have to set our right equal to mid minus 1. So we actually have to scan through this portion of the array. But in this case, we actually hit the else statement because our target is actually greater than nums of mid, as our target is 9, and at this point we're covering 7. So we have to set our left pointer equal to this middle indice plus 1. So suddenly our left pointer is currently 0, 1, 2, 3 at the 4th index, while our right pointer is still at the 6th index at the end. Okay? And now we have to check if now we know that our target is contained within this portion. And we have to keep cutting it in half until we get that nums of mid, which in this case is 9, is equal to our target value, indicated by this while loop, and we simply return that middle index. And we keep, performing these lines of code until we actually get it to get validated. So that is binary search for you guys in, 7 to 8 minutes. If you guys understood it, please make sure to hit a like and subscribe. And thank you guys so much for watching. I will see you guys in the next video. Bye-bye.